these two folks here in the front, but I haven't really talked to you. They seem to be pretty familiar with Eigenlayer. Are you all pretty familiar with Eigenlayer? Yeah. So this is kind of more of a, I would say, introductory level overview, but it's going to go into some of the stuff in terms of like what people are building. So you may or may not learn a lot. My name is Nader, and I just joined Eigenlayer. Actually, it was my first day yesterday. So this is kind of me still kind of like, getting up to speed in terms of presenting. So this will kind of dive into some of the reasons why, like, I personally am excited about Eigenlayer and why I joined the team. So a lot of times when I've talked to folks about Eigenlayer and when it's mentioned, a lot of people don't know like why it exists. They talk about staking and yields and things like that. But the reason like why it exists is actually to enable developers to build infrastructure and to build cool applications a lot easier than what was possible in the past. And that's really going to be the main focus of this talk. So if you want to get a, I would say, aggregated list of all of the different resources that I found super helpful, this is kind of a QR code, so if anyone wants to grab that. This is kind of like going to be a document that I continue to work on. So as new cool stuff comes out, I'm going to continue adding to this. And yeah, it's just probably a good place to go if you want to kind of get a curated like list of learning resources, as well as like an example code base for building an AVS. Okay, so to distill what Eigenlayer is and why it exists, I like to kind of try to come up with just very simple, almost elevator pitch types of phrases. So if you kind of look at the website and read the white paper, you might get confused, or you might kind of have not a clear understanding without spending a lot of time. So how can we kind of distill that? I think that this phrase is pretty good. The reason that it exists is to make building and consuming infrastructure easy. And we're not talking about just any infrastructure, we're talking about like decentralized infrastructure. So the reason that this is important is that it's extremely hard to build decentralized infrastructure on Ethereum because you have to actually bootstrap your own economic security for anything outside of a smart contract. So things like bridges, oracles, decentralized sequencers, all the things that we see that are necessary to facilitate horizontal scalability in the like blockchain computing space. Because of this simple fact, bootstrapping any decentralized infrastructure is difficult. And when you kind of think about just regular infrastructure, it's also difficult to bootstrap any reliable infrastructure. At AWS, I was working there for like a little over 3.5 years. US East 1 used to just go down every year. And everyone that used US East 1 would also go down. So people would be like on Reddit and Twitter and all these places, and it just stopped working. It wasn't Twitter's fault, it wasn't Reddit's fault, it wasn't any of these apps' fault, it was the underlying infrastructure. That's not counting all of the outages that happen at the actual application level for all these other services as well. So if they have an error in their database migration or any like merge that kicked off a deployment that broke something, like there were a lot of reasons why applications would fail. Because even building a regular centralized infrastructure is actually extremely difficult. But when you add the fact that you need it to be decentralized and you have all of these different nodes that need to interop and they need to come to these different agreements, and you need to kind of make sure that it is always up, it becomes exponentially harder. And when you look at all the different infrastructure that exists in the world today, there really is only one computing platform for the most part that has a long track record of 100% uptime, and that is Ethereum. So Ethereum is great and it's stable, but it's very limited in what you can do. As of today, for the most part, when you kind of think about computing on Ethereum, you're talking about writing a smart contract and interacting with it. It's slow and it's costly. So the idea behind Eigenlayer kind of extends this highly desirable economic and reliability, security properties outside of the Ethereum, I would say, network itself into all these other services, which is really, really exciting and powerful. So if you go to the docs, you might see something like this. It's a protocol built on Ethereum that introduces restaking, a new primitive, and crypto economic security. The restaking mechanism, though, is only a means to an end. The end goal is to enable developers to build easier these decentralized protocols that rely or that might facilitate some type of horizontal scalability at the network level. And I really like this phrase, that Eigenlayer can bring the power of Ethereum outside of the EVM to additional applications on the network. So the TLDR, another TLDR is that Eigenlayer's shared security for Ethereum or increasing the programmability of Ethereum. And what that basically means is the programmability of Ethereum, as it stands today, might just be writing and interacting on a smart contract. Increasing that programmability might mean building any type of infrastructure and inheriting all of that security. So what is shared security in practice? I think to talk about that, we might want to look at the evolution of blockchain networks. Because the original network was Bitcoin. It was very reliable and it works really, really well, but it only does one thing. It's a peer-to-peer network for essentially a distributed ledger. And if you wanted to build another blockchain application, you couldn't just use Bitcoin to build that. You needed to actually build a completely new blockchain. So you saw Litecoin and all these other networks that did things slightly differently. But you couldn't just extend the Bitcoin platform to build something. You had to start again from scratch. Huge ordeal, a lot of things that you could talk about going into that. But one of the biggest challenges was getting adoption, because you have to actually think about all the different network participants. And it's very, very challenging. You probably saw countless different approaches and attempts at building out these types of networks that never really went anywhere because of that. So the next, I would say, exponential improvement in ease of development were smart contract blockchains. So with Ethereum, you could basically inherit all this security and just write a smart contract and deploy it, and you don't have to worry about building out this entire blockchain network. You can just create your idea, and you can deploy it, and everyone can start using it immediately. So this is kind of like a paradigm shift in how you could build decentralized applications, because you went from having to build a blockchain yourself, and now you can leverage an existing blockchain and build out your own app. And I think that's kind of the line that we're talking about here in terms of innovation. Building a blockchain from scratch, building a smart contract on a shared network, and now we're building networks on shared security. And once we hit that limit in terms of scalability and cost, because I think Vitalik early on said 5 cents per transaction is too much on Ethereum. This was a long time ago, obviously, but we've obviously gone way beyond that. And everyone's, I think, realized at this point to scale anything, you need to scale vertically and horizontally. So what the approach is kind of look like now in terms of the Ethereum-centric roadmap is a roll-up-centric roadmap. We see teams out there building out like really better execution environments, but we also see that everyone's realized that a lot of the applications that are going to outgrow these shared networks are going to be building app chains and roll-ups. The problem is that roll-ups may inherit, the call data may inherit the security of Ethereum, but all the other infrastructure around that does not. We're talking about different virtual machines, keeper networks, oracles, bridges, data availability layers that facilitate the low cost and maybe high throughput that we can see with some of these different app chains and rollups. And the challenge therefore then becomes, okay, so we can build a rollup, the rollup call data inherits the security of Ethereum, but the underlying infrastructure still needs to be bootstrapped. All of these other things need their own security network, and also you may need to have your own native token, and you might need operators, and you have to then create different incentive mechanisms. It's just this whole ordeal. It looks something like this meme where you kind of like, oh, like you have to do all this crazy shit, but there is maybe a simpler way to do it. You have to bootstrap your new trust network, and you have to understand how to facilitate operator distribution. You have value leakage from the base layer. Validators are essentially incurring opportunity costs by securing your network, by not securing other networks they already know are going to be giving them high rewards. So you have to then attract them by giving them very, very high rewards. Therefore, like you're basically having to pay a lot at first to kind of get these people up and running. And then there's also this idea of a lower trust model, because if your application is leveraging 20 different services, then they all are secured by other decentralized networks, then the lowest point of security is the lowest, I would say, that any part of your network that can be exploited, that is kind of like all it takes to exploit the entire application. So you have the trust model is based on that lowest common denominator, I guess you could say. So the question then becomes this: what if we could look at how we have the evolution of blockchains from Bitcoin to the EVM, where developers could basically build these smart contracts and inherit security from Ethereum? How can we inherit that security to build out all the rest of this decentralized infrastructure? And that's really what the point of restaking ultimately is to enable these actively validated services that will allow developers to inherit all that security without having to bootstrap it from scratch on their own. So what it looks like today is you have this model where you have your new service here, and it's completely separated from the base layer. And the smallest of the I would say in terms of like when we were going back over here to the trust model, the lowest common denominator is kind of like the entry point for any attack or any security vulnerability. You're not inheriting anything from Ethereum. You kind of are getting the best of both worlds with Eigenlayer. And this is kind of a diagram of what the very, very base level network participants look like. You have the ABS developers who are coming up with these new ideas, and they are deploying them to Eigenlayer. Operators can opt in to then support those. Stakers can then opt in to support certain operators, and then the app developers can just build on these ABS services. And this is kind of interesting for me because this has been mainly a lot of the work that I've done in terms of developer relations, but also my own software engineering. It's always mainly around full stack application development. And I've seen a lot of the things that people are building that are ABSs, and I have a lot of ideas around what I can do in terms of showcasing some of that stuff. And I'll go over one of my favorite ones in just a moment. Another thing that this introduces is dual staking, where you can use either the Ethereum network token or your own network token to secure the network. This allows you to have a decent amount of high rewards for the people that are securing your network without having to worry about like this idea of the death spiral, where if you were only leveraging your own network token, you have this problem where if the token price starts to really drop, you then have weakened security, which then decreases the TVL, which makes the token price drop further, and then you kind of can get into this situation where it becomes really inexpensive to attack your network. This problem is essentially eliminated. So at the end of the day, these ABSs are apps that are using Ethereum Trust outside of the EVM. What are some of the categories of applications that can be built? The main ones that are kind of in my own interest and that I understand the most, to be honest, are like these roll-up services. And this is kind of like the initial excitement. Now we're starting to see a lot of this other stuff being built as well. But the initial app, the initial network service, the initial ABS was Eigenlayer. It's kind of like not only the proof of concept, but it also enables a lot of this other stuff to be even more useful. You have decentralized sequencers, bridges, MEV services. You have this category that you could call coprocessors. You have cryptography. You have oracles and MEV and decentralized storage. There's quite a few different areas that are not fit directly into any of these categories as well. And I'm going to show you kind of a list of all the different apps that are building right now. But here are some examples. I think the one that everyone already knows is Eigenlayer. This is very similar to Celestia, except for Celestia is an entire network, a blockchain network that does a lot of the different pieces that you don't actually need, I think, for what EigenDA offers. But I think they're both like valuable for different situations. I was at Celestia for about 6 months early on, and there are a lot of similarities and a lot of differences, I would say. There are, this is like another example of an area that's getting a lot of attention that you've probably seen, rollups as a service. Altlayer is one of them. And they also have something called restaked rollups, which are a nuanced version of this that are kind of interesting. I personally don't know the exact difference, but they have like a few of these characteristics that they try to kind of segment. They're trying to create, I guess, like a new category. It's kind of cool. There's Caldera. A lot of these are like leveraging existing, stacks like the OP stack or Arbitrum Orbits. This is one of the coolest projects that I know. This is cool. It's like MegaETH. If you're familiar with Monad, it's like this high performance and low cost execution environment. They're building an L1. They've done stuff like rebuild the entire database from scratch, parallel execution, etc. It's kind of like if Ethereum and Solana had a baby, where you had the EVM bytecode compatible, but you had the performance of Solana. They just raised, it's like a $200 million valuation or something like that. They're doing well. They're leveraging EigenDA. So there's a lot of different dApps and protocols that are building. We have an ecosystem out at eigenlayer.xyz/ecosystem. So you can check that out to kind of see. We have them segmented by category. So there's rollup services, there's general AVS, and then there's also operators. So you can kind of like see everything that's going on. And as that grows, we'll continue to kind of keep that up. And I saw this tweet and this post on this, I guess, what do you call them, forecaster, a cast, from Taryn. He said, after going to a few college hackathons recently, it's clear that no one else has caught technical students' attention quite as much as Eigenlayer. I haven't seen as many crazy but impassioned ideas for infrastructure since DeFi summer. Pretty cool to see. Anyway, this is that same, I think a lot of people already got this, maybe you came in a little late. But this is kind of like a curated list of resources for Eigenlayer that's going to be continued to be expanded as time goes on. I think there's like 15.
Yeah, like your ecosystem page?
It's my personal learning resource page, but this will ultimately be on the website, yeah. But for now, I would just take a picture of that.
Cool.
Or capture that.
Thanks.
Yeah, so that's it.
Could you flip to that?
Oh yeah, sure. Yeah, this has like the white paper, a bunch of links, a bunch of YouTube videos, just really relevant stuff, I think. So it gets you from like 0 to 1 real quick.
Question.
Yes.
How does a rollup as a service work with Eigenlayer? Because
It leverages EigenDA.
oh, okay, got it.
Yeah.
Makes sense.
And also, like this is my second day at Eigenlayer, by the way, for anyone that wasn't like that familiar. So I can probably answer like certain questions. I've been streaming for almost 2 years now. I first saw Eigenlayer back in 2022 and had dinner with them and asked him a bunch of questions. That was when I was working at Celestia, trying to figure out like the differences between EigenDA and Celestia at the time. But really excited to be kind of joining their team. And we're going to basically have different groups where we are supporting developers. So if you're thinking about building an ABS, definitely let me know and we can get you connected and give you that type of support. So that's about it.
Thanks, man.
When will Eigenlayer be live? Oh, sorry, EigenDA.
EigenDA will be live on mainnet when Eigenlayer goes live.
Oh, so
And there's no exact date for that, but it'll probably be the beginning of Q2.